Hey, what's going on, guys? My name is Swaggy1 Fresh here, and today we're going to show you how to do chi-square genetics practice in AP Bio Speedrun. Okay, so basically, I have the finished product already, and we're just going to go through it, because, yes, okay. So, off rip, the question asked is a sex-linked trait. Oh my god, this pencil doesn't work. Okay, and you need to do the chi-square chart. A female carrier, colorblind allele. Okay, the female is a carrier, so you know it's carrying that trait. Okay, this is not colorblind, but it's recessive. It's gonna have that trait. And mates with a male who is colorblind. So this is your genotype. It has that carrier, and that man is colorblind, and he has a Y. Okay, so you put it in a Punnett square. Get the percentages. It has a 25% chance. It all has like a 25% chance because they're all different. So once you get your calculations, you want to set up a null hypothesis. Your null hypothesis is literally your phenotype. Your phenotype is normal female, colorblind female, normal male, colorblind male. So when you do a null hypothesis, it's literally this. It's all the options. So we got a point. Oh my god. 0.25 chance. 25% chance, 25% chance, 25% chance. That's your null hypothesis. Your null hypothesis is already done. So next thing you want to do is find your expected. So okay. Your total observed is how many were bred in total. So there were 520 children produced by these two wombats. Okay, so you get the total. 520 times 0.25. Since they're all 25, they're all going to be the same number as expected. So 520. So you want to set up this entire thing right here. It's the observed, expected, like that. And then observed minus expected, this minus that. And then once you get this, you want to square it. Then once you get that, you want to hit it with a little divided by expected. Once you get that, you're gonna get this number, observed minus expected squared divided by expected. So you'll get these calculations, and your sigma is literally just adding all these numbers up. Your total is this number right here. And once you get that, you want to look on your critical chart. Well, where on the critical chart? I mean, not critical chart, but degrees of freedom chart. You want to see how many degrees of freedom you actually have. So in this one, we have 4 different types of phenotypes. So you want to get your sum of phenotypes minus 1. That's all. That's all. And that's your degrees of freedom. Your chi-square value chart, degrees of freedom, and our number was 0.6922. Let's go to 3. This is your critical chance, and you want to get something less than the critical chance, which is, if you get something here, that means it's like really rare, and if your calculations are off. So you want to get that number, and it accepts the null hypothesis. So you're literally done with the entire question. It's less than critical value, degree chance of 3, and p-value point whatever. Okay, null hypothesis can be rejected. Wait, oh god, it cannot be rejected. Sorry. Okay, it cannot be rejected, and the data does fit the depicted phenotype ratio. And you're done. You're literally done. You just sped run it. You sped run chi-square genetics practice. I hope it made sense.